Okay, let's go ahead and get moving on with our exponents. In the last video, we multiplied powers that had the same base. So remember, as just a refresher, you want to keep the base the same, so you don't want to multiply them. You want to add the exponents and then simplify as much as possible. Just a quick little review. If we had 3x to the third times 3 squared x to the negative 2, numbers that have the same base, you add the exponents. So this 3 and this 3 squared have the same base, which is 3. Even though it's not written here, the exponent for this 3 is 1. So we get 3 and then 1 plus 2. Then x is a base for our leftover terms, and we have 3, and we're adding to that a negative 2. Simplify, we have 3 to the third times x to the first. Remember, this is 3 minus 2. 3 to the third is 27, and we don't write the first power, so we get 27x. That is simplified. Also, just remember that the reason you add these exponents is because you're really counting how many of the number there are. So if you have 4 squared times 4 to the third, remember that this means 4 times 4, and this means 4 times 4 times 4. So when you are multiplying all of those, you have a total of 5 4s, so it's 4 to the 5th power. So this is saying you have 5 of this number. As we move on, so remember exponents, what they mean, like I was just showing you. Y to the 4th means y times itself 4 times. Now this one gets a little tricky. This is the first time we've seen an example where we've had something other than just one number or one variable being raised to a power. Here, because the 3x is in the parentheses, this means you're taking 3x and multiplying it by itself. Now here is where we can combine 3 times 3 to give you 9. And then remember, this x has an exponent of 1, this has an exponent of 1, so we get x squared. In this second example, 2 has an exponent of 1. So remember that even though it's not written there, exponent of 1, where in this portion of the example, this whole 4m has the negative 3 exponent. Remember, negative means you move it to the bottom of the fraction, so you leave the 2 as it is, move the whole bottom, or the whole 4m to the bottom, make it a positive 3 exponent. So really, this is saying we have this on the top, and then 4m times 4m times 4m. So again, 2 in our numerator, and in our denominator, we have 4 times 4 times 4, which is a total of 64. And then we have m, and remember these are all to the first power, first, so we have m to the third, and this would be your simplified version. Okay, so let's move on and talk about when you raise a power to a power. So you're taking an exponent and raising it to another exponent. So here's what happens. If you have an exponent raised to another exponent, you multiply them. So if you have, for example, 4 squared, this is being raised to another exponent. So 4 is being raised to the second power, and then again to the third power. That would give you 4 to the 6th. And simplify that, which gives you 4,096. Now let me show you just why that works. This 4 squared to the third means you have 4 squared 3 times, right? Okay, now using what we did in the last chapter in 7.3, we said if you have the same base, you add the exponents. So same base, 4, 4, and 4. Then we add the exponents. 2 plus 2 plus 2 is 6. Okay, see how that works? And then same here, 6 to the negative third, and then raised again to the second. Multiply the powers, give it a positive exponent, so it comes down into the denominator, and then simplify. So this one, if we left this and as a 1 over 6 to the positive third power, like that, and then squared it. Remember, that's taking 1 over 6 to the third and then multiplying it by itself, which is 1 over 6 to the third. And again, following the rules from our last lesson, 6, 6, same bases, so we add the exponents, which gives you 1 over 6 to the 6th power, which is right there. Okay, now in the next section, and not section of the book, but section of the rules, if you have a product meaning a number times a variable, so a product, number times a variable, okay? So what that does is it takes you raise every single term inside the parentheses to that power. So 3 gets raised to the third power, and so does x. Okay, so what I did here was take the 3 to the third, x to the third, simplifies 27x to the third. Now, if we look at what this is saying, it's really telling you that you have 3x 3 separate times, right? So 3x to the third power means you take 3x, multiply it by itself 3 times. And now what you have is 3 times 3 times 3 to give you 27, and then x, same base, and the exponents for each one is 1. So then you get x to the third. Okay, second example down here, raising 5 to the 4th power, and then y to the third again to the 4th. So what this example really is saying is you're taking this product, 5y to the third, and you're multiplying it by itself 4 times in a row. So that's really what this is asking you to do. And when you do that and multiply and combine all of your like terms, you end up with 625y to the 12th. Now look back at what I was just showing you here. 3x squared, remember we split it, 3x times 3x. And then you'll also notice that 3 squared gives you 9, and then x squared, or x is x squared, so we took this 2, essentially, and applied it to all terms inside. We did the same thing here, only we made this a positive exponent first. So we switched to make a positive exponent first. Okay. Now, if you think about something that we've done before, a property that we've used a million times, the distributive property, that's basically what we're using, just in a little different way than what we're used to seeing. So we're taking this, for example, in this example, we're taking this 3 right here, and we're distributing it to every single term inside the parentheses, which is what the distributive property does, right? So the distributive property is taking a number and multiplying it by everything on the inside. So you would take that 2 and take that, multiply by the x and by the 3 to get 2x plus 6, right? Okay, so now if we have x, I'm sorry, not x first. If we had 3y x to the third, we're taking this 3 and raising it to the third power, this y raising it to the third power, and the x and raising it to the third power. So it's just like this property, it just looks a little bit different. It's with exponents. So let's go ahead and do some of these. With this example, remember, you have b raised to the -6th, raised again to the third. So when you raise it twice, you multiply. Okay, so raise, then raise again means multiply. All right. So we leave our base as b. -6 times a +3 gives you a -18. Now remember, when you simplify, no negative exponents. Remember? It's just something you don't do. You want all positives. We only have the one term here, so we just take 1 on top, put b in the bottom of a fraction, and there you go. Another one here, a little bit tougher. It's going to combine both what we did in the last section and in this section. If you see this y outside here, this is not being raised to the third power. This third power is only being raised to the numbers and the terms that are on the inside of the parentheses. So that 3 out there is only connected to those terms. So this y is going to stay as it is. Now in the parentheses, remember you're distributing to everything inside. So you're raising it to the -4th and then raising again to the 3rd. So you get x to the -12th power. And then we're taking y, and there's no exponent, which means it's a 1. So y to the 1st and then again to the 3rd. So we get y to the 3rd power. And now we simplify. Remember, same base means you add the exponents. So we get y to the 4th, x to the -12th, and now we don't want any negatives, so we switch that down to the denominator. Y to the 4th remains in the numerator, and x to the 12th is now your denominator. Now this one looks a little bit tougher. In reality, it isn't. We're still just distributing. Now if you look closely, this whole section right here has a second power, whereas this whole section over here has a -4th. So distribute that 2 to all of the terms. So we have a to the 3rd to the 2nd. Okay, so remember that's raising a power to a power. So you get a to the 6th, and then b to the -5th to the 2nd gives you b to the -10th. Okay, now with this one, we're distributing again. All right, so we get a, now we have it to the -3rd, and then again to the -4th. So since -3 times the -4 is 12, that's our new exponent for this a term. And then we have c to the -5th to the -4th again, so multiply, and you get a +20. Now remember, you always want to simplify as much as possible. Okay, so you never want negative exponents. You don't want to leave terms uncombined that can be combined. So looking at our example, we have a to the 6th and a to the 12th, same base. Okay, so same base, remember. So that means add the exponents, all right? So we take a, and it is now at the 18th. Sorry, pen's freezing up. All right, so a to the 18th, and then b cannot be combined with anything, and neither can our c. But our b has a negative exponent, so we keep a in the numerator. We keep c in the numerator because those are both already positive. Move b to the denominator. Ta-da! There's your answer. All right, now there's just one extra little tip that I want to show you, and this is with exponents and fractions. Remember that raising something to a power means you're multiplying it by itself 3 times? Well, depending on the exponent. So for this example, it would be 3 times. Whoa, I have no idea what just happened right there. Sorry. So this would be 2 to the 5th times 2 over 5, times 2 over 5. Now when you multiply fractions, remember, straight across, okay? You're going straight across numerator, straight across the denominator. So 2 times 2 times 2 gives you a total of 8, and then 5 times 5 times 5 gives you 125. All right, now with this one's a little tricky, negative exponent. What's kind of nice about this is any fraction, and I'll even write this out for you, any fraction raised to a negative exponent, flip it. Okay? So we're going to flip it and make it 4 over 3, and then a +2 as our exponent. So we get 4 over 3 times 4 over 3, which equals 16 over 9. Now you notice with this example, if we just took our 2 and raised it to the third power, that is our numerator. And if we just took our 5 and raised it to the third power, that's our denominator. So really, that's all you're doing, taking your numerator, raising it to the power, and your denominator. So you're doing all terms inside the parentheses. Now same here. Let me show you why this portion works. Why can we flip it? So why can we flip? How does that work? Well, let's say we use the rule that we found up here, applying our third exponent to all of the terms. We would have here 3 to the negative 2 over 4 to the negative 2. And then how do you make an exponent positive? Well, you switch where it is in the fraction. So if it's negative in the numerator, put it on the bottom, becomes positive. If it's negative in the denominator, then you move it to the numerator and it becomes positive. So again, we end up with 16 over 9. Ta-da! Yay! All right. And one more thing, and I think this is just because somebody asked this in class, fractions as exponents, and yes, you can have that actually, and that is something you really already know, you just don't know that you know it. Square roots. Ah, it did it again. This board has a mind of its own today. Okay, so you know that squaring, to square a number, means that the exponent is 2, right? Okay, but if you take the square root, that's this little symbol. All right, so you know how with x, we don't write 1x, and we don't write 1x to the first power? Well, the same kind of rule applies with the square root. There is an invisible little 2 right there that we just don't write. It's implied. So what happens is if you have this right here, the square root of x, this would be to the first power. And when you write that, this actually becomes x, and then you take these exponents here and here, and you write 1 over 2, just like that. So I'll show you another little example because it's pretty cool. So let's look at if I had the square root of y to the third. Now remember, there's a little invisible 2 just outside of that little square root, so we take the y, the 3, this 3 here becomes our numerator, so we have 3, and then 2 is our denominator. There you go. Now do you remember talking about cubed roots? Because cubed roots were the opposite of cubing a number. To cube means that the exponent is 3, right? Okay, so if we take the cubed root, we had something that looked like this, looked like the square root, but it had a little 3 here. So the exact same rules apply. If I wanted to take the cubed root, of, let's say, b to the, let's say just b. Well, the exponent here is 1, even though we don't write it. So really what we end up with is b. Remember, this becomes your numerator, 1, and then this number out here becomes your denominator. All right, and so it's b to the 1/3. And there you have it.